Hey guys, my name's Ed Galinsky. I'm the lead training instructor here at US Aviation Academy Denton campus, and I'm here to tell you how a turbine engine works today. All right, so here we have our beautiful Rolls-Royce Spey engine. Developed by Great Britain, it delivers about 12,000 pounds of thrust and was used by multiple different instances of military and commercial aircraft, mainly Gulfstream and their G2 and G3 aircraft. In this engine, we have three main sections. We have a compressor area, we have a combustion can section, and we have a turbine section in the back. The base fundamentals behind how this works is astronomically simple. We take in a bunch of air and compress it as much as we can. Imagine if we had a ceiling fan, like what's in your house. That ceiling fan pushes air down. If we were to stack ceiling fan on top of ceiling fan on top of ceiling fan, we would move a bunch of air all at once. We do that in our turbine engine with a series of ceiling fans we call compressor blades. Those compressor blades move air throughout the compressor of the engine where the cross-sectional area decreases significantly. So we're shoving a bunch of air into a smaller and smaller and smaller area, compressing it. Once it gets to the end of its compression area, it is fed into a combustion section. This combustion section mixes it with fuel and then ignites it. That burning fuel-air mixture is pushed out of these combustion cans and hits what we call a turbine blade. Now, just like if you turn on the ceiling fan at home, it rotates and pushes air. This ceiling fan is actually being turned by the pressure coming out of the burner cans. So air comes in, it's compressed, compressed, compressed. Air is ignited and then shoved through a ceiling fan. When we shove that air through this fan, that causes the fan to rotate. We harness that energy and use it to rotate these compressor blades. So the whole thing is powered by itself. We compress air, we ignite air, we use that air to rotate a fan. That fan spins the compressor, which continues to compress air, which is then ignited, which spins the fan faster, and so on and so on. So we talked earlier about a set of ceiling fans that were stacked on top of each other. We can see those ceiling fans right here in this engine's compressor section. We have two sets. We have one set, these right here, will rotate in a circle the entire time the engine is running. We have another set right here that don't rotate. These that don't move are called stators. The ones that do move are called rotors. As these rotors spin, they suck in air, and because they're rotating, the air wants to spin with them. These stators will grab that air and redirect it into the next best angle so the next stage of spinning rotors can suck that air in. Now, as it goes along the length of the compressor section, its area that it occupies is smaller and smaller and smaller, shoving those air molecules closer and closer together, all through this compressor section right here. That air is being compressed throughout this entire compressor section, and as it's being compressed, it's getting kind of angry. It's not happy about being shoved so close to all the other air molecules. We deal with that with this section right here called the diffuser. This diffuser will slow all that compressed air down, compressing it even more, and guide it into these combustion cans. About 30% of that air is going to go into the middle of these combustion cans right here. The remainder is going to flow on the outside of the combustion cans and flow inward. That air is mixed with fuel and ignites during the starting process. And the entire time the engine is running, that fuel-air mixture is burning. This air flowing around the outside forms kind of a hot pocket of fire. And that hot pocket of fire, as I said, burns continuously. The gases from that hot pocket of fire come back and hit this turbine wheel. This turbine wheel is just another ceiling fan. The air flowing through it forces this fan to spin. This fan is directly connected to those compressor blades we saw up front earlier. This fan spins, the compressor spins, We ignite the fuel air mixture, causing the fan to spin faster, causing the compressor to spin faster, causing the fuel air mixture to burn a little bit hotter, causing the fan to spin faster, so on and so forth. The entire process is completely self-reliant. The only thing we really do to it is add fuel.